Welcome back to our series on AI and machine learning. In this lesson, we'll dive into some key concepts in machine learning, including algorithms, models, and the processes of training and testing. We'll also discuss the important topics of overfitting and underfitting. These concepts form the backbone of how machine learning works and are essential to understand as we progress. Let's start with algorithms. In machine learning, an algorithm is a set of rules or instructions given to an AI, which it uses to learn from data and make predictions. There are various types of algorithms, but two of the most fundamental ones are regression and classification. Regression algorithms are used to predict continuous values. For example, if you want to predict the price of a house based on its features like size, location, and number of bedrooms, you would use a regression algorithm. The goal here is to find the relationship between the input features and the continuous output value. On the other hand, classification algorithms are used to categorize data into discrete classes. For instance, if you're working on an email spam detection system, the algorithm would classify emails as either spam or not spam. Another example is a medical diagnosis system that classifies tumors as benign or malignant. Next, let's talk about models. In machine learning, a model is a mathematical representation of a real-world process. It's built using the algorithm, which learns from the training data and finds patterns in it. Once trained, the model can make predictions or decisions without being explicitly programmed to perform the task. The process of training and testing is crucial for building a reliable model. Training involves feeding the model a data set so that it can learn the relationships between the input features and the target outputs. Typically, we split our data into two sets, a training set and a testing set. The model is trained on the training set and then evaluated on the testing set to see how well it performs on new unseen data. This brings us to two important concepts in machine learning, overfitting and underfitting. Both of these are related to how well a model generalizes to new data. Overfitting occurs when a model learns the training data too well, including its noise and outliers. While the model performs exceptionally on the training data, it fails to generalize to new data, resulting in poor performance. This is because the model has essentially memorized the training data rather than learning the underlying patterns. On the contrary, underfitting happens when a model is too simple to capture the underlying patterns in the data. As a result, it performs poorly on both the training data and new data. Underfitting indicates that the model has not learned enough from the data. To illustrate these concepts, imagine you are trying to teach a child to recognize animals. If the child remembers only the specific animals in the pictures you showed during training and cannot recognize new animals, that's overfitting. If the child cannot even recognize the animals in the pictures you showed during training, that's underfitting. In practice, we aim to find a balance between these two extremes. We want our models to generalize well, meaning they should perform adequately on both training data and new, unseen data. This is achieved through techniques like cross-validation, regularization, and by using more complex models or better features. In conclusion, understanding these key concepts, algorithms, models, training and testing, overfitting and underfitting, is fundamental to mastering machine learning. These concepts help us build models that can effectively learn from data and make accurate predictions. In our next lesson, we'll explore the different types of machine learning algorithms in more detail, including some advanced techniques. Stay tuned.